Hello, welcome if you've joined and you can hear me, do let me know in the chat. Hopefully you've just seen my colleagues just drop the link there for the slides. Welcome if you're already watching. We'll give it a minute or so anyway to allow people to join. Excellent, hi, excellent. Some Snap Revise regulars there joining already. Good to see you all logging on straight away, which is great. Hi, cool. Excellent. So we're going to look at histograms today. So we're going to kind of go through a key part of the statistics part of the A-level. Welcome. Hi, excellent. I can see your messages if you're just joining. This is an A-level maths statistics-based histograms web class today. So we're going to look at this together as part of the Home Study Club. And as I've said before, Mondays and Wednesdays, we're running these for maths. So it's really good for the A-level to kind of get ahead if you haven't covered this yet, or as a bit of a revision session. This is a topic that is on the GCSE now, but it's kind of extended a little bit at A-level, so we need to look at it together. Excellent, lovely to see you all in the chat, and thank you for joining so punctually as well. We're only just starting, so that's brilliant. I am going to share my screen shortly. We'll just give it a chance for other people to log in. I hope we're all doing well, hope we're keeping well. I'm sure probably keeping busy. It's hard to kind of relax sometimes when we know we're still juggling the workload that we need to get through, we would be getting through at school. Excellent. So what I'm going to do today is when we go through the questions, I will pause for a bit of time for you to, give you a chance to work through it yourself. It's quite a nice topic, fairly straightforward. Hello, welcome. If you've just joined, I can see in the chat there, that's lovely. Right, so we're going to look at histograms, and I'm going to share my screen now so we can get started. Let's have a little look. So keep me updated that you can see this all when you can hear me and everything in the chat, because I can still read those messages. So can we see my screen there? This is the histograms bit. Hello, welcome if you're just joining. Hopefully that has now taken over the screen and I'm in the corner and you can see my slideshow, but do let me know. Cool, hi, welcome. So we're going to be doing histograms today, which is part of the A-level statistics, part of the applied side of the course. And a common question we often get is, what exam board is this relevant to? This is really relevant to all boards. A lot of the stuff we're doing is going to be related and relevant to all exam boards at A-level. And as I'm sure you're aware, there was a big change to the A-level in 2017, and there's a lot of stuff that's been sort of compulsory across all boards. And now everyone has to sort of cover statistics and mechanics as well as the pure. So what we've got going on here is we're going to look at part of the typically year 12 statistics, and we're going to look at histograms. So let's get started. Hopefully we can all still see and hear that well. Brilliant. Welcome if you're just joining. It's great to see so many people taking part in this. So towards the end, as you're probably aware if you've been to one of these sessions before, we'll do a discount for Snap Revise, where we offer a lot of extra resources and web classes and tutorials on our platform. So if you are interested and you are enjoying these sessions, that will be there at the end. And we're going to look at histograms today. So this might be very familiar to you from GCSE, or maybe it's something that you're quite confident with from the A-level. Excellent, right, some great comments coming in. And yes, we will be looking to do a bit of mechanics and a bit of stats, and obviously the pure in these classes. So you can also access the previous sessions that we've done on YouTube as well to see, what other topics have been covered so far. But here we go, let's look at this one together. And as I said, one of my colleagues has dropped the slides into the chat. So if you did want to access this and work through alongside me, ahead of me, that's fine. Any suggestions how we go about this one? So we need to be kind of careful. Histograms are a way of displaying grouped data, grouped continuous data. And what we've got is continuous being, obviously time is the continuous variable here. And we need to be careful because it's a little bit different to a bar chart and stuff. It's continuous data. So what we need to look out for is how we deal with this. And we have this axis, which is the frequency density. So hopefully from GCSE, we recognize that the area of the bar generally represents the frequency. Lovely, and some people have dropped some comments in there as well. That's superb, yeah. Now, the key difference at A-level, or not difference, but little point to clarify, is the area is proportional to the frequency. Because obviously we can use any scale we want for that axis, and we could make one box equal to 1, centimeter squared and so on. But we need to work out the level of proportionality, the factor, and how it links. Absolutely. So what we're going to do here, if you have got any suggestions how we do this one, feel free. I'm just going to give everyone a chance to have a little think. Hopefully quite a nice one to get started. Use what we've already got and what we know to work out how we're going to find these values from the frequency, given that we've been told the histogram. So any ideas, any suggestions for the 18 to 25 value? Okay, right, super. We've got some answers coming in. Absolutely, yeah. So hopefully you've noticed that this area here represents a frequency of 10, and it's 5 wide, and it's got a frequency density of 2. So it's got an area of 10, and it represents a frequency of 10. So this is quite a nice one. So absolutely, well done. We're flying through these first questions already. That first answer is going to be 35. So you're just going to calculate the area for the 18 to 25 part. And then for the next bit, some people have got it there as well. This width times that height, and we're going to also get 15. Good. Super. So brilliant. Right. Well, that's quite reassuring. I'm glad to see that this is hopefully making sense to people. Right. We'll go a little bit more A-level style now. So feel free, as I said, to work ahead of me or alongside me as we go. Now it says estimate the number of people who took longer than 20 minutes to swim 500 meters. So answers here, what do we reckon? So number of people more than 20 minutes, and let's just look and be careful at where that is. And also have a little think about why this is an estimate. So please do also feel free to comment as to why this is an estimate, because sometimes in statistics or in A-level maths, people think, okay, estimate, I can just kind of do this really roughly and, don't have to do it exactly. What is making this scenario an estimate? Okay, so good, some good suggestions coming in there. We want the value of kind of this area, and also, as someone said here, this last kind of bar or box area as well. So bear in mind that that value was from 18 and it is grouped, and good, some really good points coming in as to why this is an estimate. So you can work it out exactly, find that area, and hopefully we can go, well, 25 take away 20. So that's got a width of 5 and a height of 5. So we're basically doing that calculation, working out that area times 5 plus the 40 take away 25 times 1, and we get an area of 40. So we reckon that that would represent 40 people. Brilliant. Super. So well done if you got that. But going back to my point as to why this is an estimate, it does come down to the factor of splitting a box, and we're making an assumption without even really saying it here. We're assuming that all these data points, all these values are evenly spread out perfectly within that interval. Because we don't have the raw data, we just know that this amount of people lie within 5 to 10 and 18 to 25. So it's not an exact, it is an estimate, because we don't know that the spread is perfectly, uniform within those intervals. But very good, that's excellent. Let's keep going because that's looking good. So here, this one, very easy to confuse and overcomplicate this question. So what we've got here is a histogram was drawn to represent this information. And it tells us that the 10 to 15 class has a width of 2 centimeters and a height of 5 centimeters. And it asks us for the 16 to 18 class, find the width and the height. I'm going to give you a minute or so to think about that. And this is one that's so easy to overcomplicate. I think the thing we also need to stress is that because it's continuous data, we need to be very careful of what the actual widths are. Okay, so yes, so that is something we need to pay attention to. Good. So 10 to 15 if we were to think about the actual width of that interval, it is actually kind of really like going from 9.5 to 15.5. There should be no gaps if we're taking decimals. So the actual width of it is actually 6. Okay, 10, 11, 12, 13, 14, 15. You could think of it that way, but it's spread over from 9.5 to 15.5. And the next interval would be from 16.5 to 18.5. So actually, what fraction of this class width is this one? And that's a really good comparison and an easy way to do it. Okay, so this is kind of 6 wide, whereas this is how many? Good. So actually, that's really useful because although it doesn't look obvious from here and here, this is half the width of this. And that's something that can really help us, but we need to be careful. Absolutely, yeah, I'll clarify that point. This is continuous data. X is a continuous variable, and we know that because we're talking about a histogram. So that means that it hasn't got to just be discrete values, 10, 11, 12. We're assuming it can be any value in a continuous interval. So this really goes from 9.5 up to 15.5. And then, and we could think of it as like an inequality. You might have seen this in linear interpolation if you've done that before, as this sort of interval. And then the next one would start from 15.5, but with an or equals. So the actual width of this class is 6, which isn't necessarily obvious. And then if you did the same here from 15.5 to 18.5, the width is 3. So the actual width of this on the axis would be half the width of this first bar. And that's where we need to be really careful because that actually makes the next bit a lot easier. Now, we know that for this class, it had a width of 2 and a height of 5. So if this something that has a width 6 has on our diagram has a width of 2 centimeters, what will it be for this one? Whoops, sorry about that. What will it be for this? Excellent. So this one will have a width of 1 centimeter because it's on the same axis, same scale. So because that's half the width, it would be half the width on the histogram as well. Now, the height we've got to be careful with because this is now determining the area. Okay. Now, what we could first do is work out the area of the original bar. Lovely, and well done if you got 1 centimeter there for the width. I'll just give you a minute to think about what the answer to this one will be, because we now need to be careful. Bearing in mind the height represents the frequency density. Have a little think. And we do know all the information about the first bar. We know its width, we know its height, and we also know that it has a frequency of 15. So that area is a frequency of 15. Brilliant, some answers coming in. I want to just check we're all on the same lines, if we agree, and so on. And feel free to comment or ask any questions as we go. That would be brilliant. Cool. So, yes, I think we'll check this one now. So what we have is the first bar has a 10 centimeter squared area, and that represents, let's say represents 15 people. So basically, let's work out what one person is represented by. So if I divide 10 by 15, so 10 over 15, which is really the same as 2 over 3, represents one person. So 2/3 of a centimeter squared is one person. So this is kind of the factor I'm using. And if I times that now by the frequency I want, okay, so 2 over 3 multiplied by 9, I get 6. So it will need a height of 6 centimeters in order to, be in proportion and represent 9 people. Brilliant, well done if you got that. I think that was already quite tricky in comparison to the first question. It's already quite a jump. Excellent if you got that. I'm glad obviously people are following, but please do question any of this because it's all very much actually about proportion and scaling and doing it in a careful way. It is a bit confusing. So just to clarify, this first interval represents 15 people. It has a frequency of 15. And that's represented by something with a width of 2 and a height of 5. So an area of 10 basically represents 15 centimeters squared. Sorry, equals 15 people. So 10 centimeters squared equals 15 people. Yeah, absolutely. So just to clarify, now for this one, we want to work out, well, what area would represent 9 people? And obviously it's going to have to be less than the previous one because we're talking about less people. So if 10 centimeters squared represent 15 people, then basically every person is 2/3 of a box, or you could think of a centimeter squared area, or you could think of, well, what is the factor from here to here? Because I need the same for over here. And what we can quite easily see is the area is 2/3 of the actual value. And remember, it is multiplicative because we're dealing with proportion. So you don't go, oh, I'll just minus off 5. You have to go, how do I get from 10 to 15? So this will then be 6, okay? Yeah, yes. So we need to be careful as well, because remember, we're dealing with area. There's some very good questions coming in, and I'm very grateful that we're checking this as we go so thoroughly. So this area will be 6 centimeters squared, and hopefully understanding the sense of proportionality there makes that make sense. We do have to be a little bit careful with just dividing the height and stuff, because what we know with histograms is that the x-axis bit can vary. It doesn't have to be the same width every time. And because we're dealing with an area, which is a kind of 2-dimensional property, you have got to also be mindful and keep track of what's going on with the base length as well. So just be aware of that, because we're dealing with areas and not so much, it's not just the height or just the width, it's the overall area that's proportional to the frequency. So for the comparison there, just picking up on some of these questions, as I said before, on the x-axis, the size of the different classes can vary. So you have to, for something like this, you have to compare both, because they've told us what's going on with the width, what's going on with the height. And now the width is referring to how wide it is in terms of the axis. So this first box was going from 10 to 15, and it went up so high. But then the next one is going from, so it really would have gone to 15.5. But the next box is going from 16 to 18. So it won't be as wide, because remember, it's got to be on the same scale, on the same axis. So we need to be really careful there that we ensure that we keep the widths in line with each other in terms of being in proportion on the same axis, but think about the overall area to determine the height, because the height is actually the frequency density. So hopefully that's okay, but we're going to do more of these as we go. So you are comparing area, but obviously the actual widths can change as well, because that's how histograms kind of work. And for those that have maybe seen this before at GCSE, you'll be familiar that they're not the same width bars even, so they're all over the place at times. So let's have a little look at another one, and I'm happy to backtrack or go over anything if we're unsure. Let me just read this, because I'm not sure if this is cut off or blocking your question. So this histogram shows the time taken to the nearest minute for 140 runners to complete a fun run. And we're going to use the histogram to calculate the number of runners who took between 78.5 and 90.5 minutes to complete the fun run. Okay, so the way we're going to go about this, again, I'll give you a chance to have a little think ahead, but look at where this is on the histogram. So it's quite nice because this is one single bar. It's not cutting into any other bars and stuff. So give this a go, have a little think, and let's see what we've got going on here. Now, if this is a little bit tricky to read, I'll write out what we've got going on. So we've got widths, and we'll do the frequency densities. And I'll just sort of list these out for you so that it's hopefully nice and clear. So we've got first one, kind of 1. So we've got a bit of a scale. Okay, good. Some good questions coming in. Yeah. So let's have a little think about and I'll just clarify what I'm doing as well in a second. So what we've got, and we've got another one in there. Okay, so the first one, the frequency density is 6, then it's 7, then it's 2, then it's 6, then 5.5, then 2, then 1.5, then 0.5. So what I've basically done, and good, I like that people are looking for a scale factor and seeing where they need to go from here. What we've got going on is the widths I've just kind of told you from here. So what we've got is a width of 1, width of 1, a width of 4. And I thought, it was a bit tricky to read perhaps, so I just thought I'd list those out. And then I've also given you the frequency density, which is the value on the y-axis. Now, what we can do with that is we can have a little think about, okay, if I multiply these through, I can start to work out what I've got going on, what total area I've actually got. So if you multiply these things together and add them up, has anyone worked out what the total area of all the bars is? So if we do the 1 times this and so on, and we work out all these different values, hopefully we find an area that we can relate to 140 and kind of work out that scale factor. Because we're absolutely right, that is the correct method you want to be using. So feel free to share your answers. Lovely. That's great, Abby. So you've got the answer as 70 for the area. So what that means is it's kind of double to get us to the total amount. Super, excellent. So 70 is the area, and that represents 140 runners. So quite a nice sort of scaling as well. Lovely. Good. And if you refer to a scale factor as k, then k equals 2. Brilliant. So what we're looking to do for this part of the question is work out what this bit represents, because we're asked to use the histogram to calculate. And notice that this one says calculate, not estimate, because it's not cutting into another bar, so we're not assuming anything. That area should fully represent what it represents. Brilliant. Lovely. So if we got this, that's superb. And lovely, thanks for showing your calculations where you can, guys, as well. That's brilliant. So it's basically 90.5 minus the 78.5, which is 12. And we're going to do that times by a height of a half, times by the scale factor, which was 140 over 70, which is 2. So it's basically 12 times a half times 2. So it represents 12 people. So very well done if you got that. That's brilliant. Any questions there, or is that kind of clear so far? And thanks so much for engaging as we go with this, because sometimes it's quite a, maybe a relatively straightforward topic, but it is still really good to iron out all the little points, and also exam technique. You don't want to overspend time on this question, but there's such a breadth to the way the questions can come up that actually you're getting your brain in gear to do something completely different to the previous question can take a minute sometimes. So excellent. Why did we do 140 over 70? That's a really good question, and I'll just clarify all of this. So the total amount of area of all of this, if you worked it out, using your width times your height of everything, 1 times 6, 1 times 7. If you work out the whole area of all of these bars, it's 70. And we know that this represents 140 runners. So the area of 70 represents 140. So basically every one, basically we have to times it by 2. So we double the area to give us the actual number of runners. That's what the scale factor is, because we know the area is proportional to the total, and we know the total amount of people. And then that idea obviously filters through, because that will apply to every bar. You double it by that same scale factor. That proportion will give you the number of runners in that class, in that interval. Does that make sense? Is that okay? So a really good question there. Yeah, excellent. And that's where this is a bit of an addition onto the GCSE, because we take it as the area just equals to the value at GCSE, whereas here we're appreciating it as an area proportional to the value. So the same scale factor translates all the way through, but we need to be careful that it doesn't just mean that's the answer, the area. You have to make sure it relates to the other parts of the question. So very good, very well done with that. I think we're doing well. Let's keep going. So as I said, the link for the slides, if you want to work ahead, is in the chat. Feel free to use that. Some of you probably are, from what we can see. This one's quite tight to read off the little intervals, but we'll do this together. And again, you're given information. Bearing in mind, again, this is continuous data, and I don't really like how they're displaying this because but that's how they do it. 4 to 6, because we know it's continuous, so it's bounded completely. There's no gaps, and it looks like from that there's gaps. So what we're going to do here for this one is we're going to think about the 7 to 8 category and the 16 to 20. And if anyone has any suggestions, please let me know. Just check that question there. Height of 0.5. Was that with reference to the previous question? I think that question that's just come in the chat was about this slide, and that's because this height was a half. Okay, it's a bit hard to see, but I did write it up here. Okay, cool. Hope that's answered it. Yes, brilliant. Right, so let's have a little look, because I'm going back to this one now. I've got to be paying attention. Good, yeah, you need to think about the intervals. Very good. And this one, it's actually easy to overcomplicate this, because you are right in that we're thinking of it going from 3.5 to 6.5, but also the areas represent the proportion of the frequency. So don't overcomplicate this one, because it's very doable from what we know is the motorists, and we can quite easily work out areas. Okay, so use that information to help you. Just to repeat that question again, a half was the frequency density on the previous slide. Okay, it maybe looked like it was 1, but if you measured it across, it was a half was the height. Okay, so I hope that's answered it. But yeah, any suggestions for this one, please feel free to share them. We're going to run through it in a second anyway. And very well done again, guys, because although this is something you maybe think this should be okay, a lot of people do make mistakes with this topic. So definitely worth ironing out the issues. It's very easy for all of us to make numerical errors, let alone actually misinterpret the question sometimes. So good, right. Let me know any suggestions for this one. Right, so be careful here, because this actually will have a width of 2. Okay, so very good, and thank you for sharing the suggestions there, because again, we're either going to be right or very close. So the first one will actually be 14. You're going to do 2 times 7. And yeah, that's good. So that one will be 14. And this one here, okay, has got a width of 5. And so it's going to be 5 times a height of 1. So that is going to be 5. Okay, very easy to mess this up, and also even look back on it and think, is that right? So look at the widths, and remember this would have a width of 3, because it goes from 4 to 6. So you could think of it as 4, 5, 6, a bit like that. Or you could think, well, it's really going from 3.5 to 6.5. Okay, and that has a width of 3, because this is continuous. So you've got to be so careful with that. And then when you go, oh, okay, so if it's 3.5, if it's got a width of 3 and it's got a height of 2 and it represents 6 people, then that's it. The scale factor is 1. So very easy to do. So that's a really good point. Like now it's going, well, do I need the scale factor again? The thing you got to look out for is if that value, when you multiply them, doesn't represent the frequency, then you need the scale factor. But because that actually has an area of 6 and it represents 6 people, K is 1. So a really lovely question there, because it does look like I've just said worry about the scale factor and then we didn't need to worry about it. But that's a really good point. So you do that when the number is then not equal to the area. So if the frequency didn't equal the area, then you need a scale factor, because it means it's proportional to it. So hopefully that's answered your question, Charlotte, but a really good point, because we've now moved to an example where it's quite nice. But do still pay attention to this one, because where the where the widths are kind of varying, we still need to be careful here. And also it can be quite difficult to read sometimes. I mean, this is quite representative of what you could actually be faced with in an exam. So let's have a little look. Well done on that one. So now we've got all our values. Now the next question is sort of a follow-up on this same scenario. I don't know if my little screen is blocking the question. I think you can just about read it there. It says estimate, so it's another one of these, the number of motorists who are delayed between 8.5 and 13.5 minutes. Okay, brilliant. And I like that we're referring, it's a bit like linear interpolation, absolutely. That's why it's an estimate, because we're splitting an interval partly. We're assuming this uniform distribution across that interval. So we're looking at for between, I can't see it now because my face is blocking it, 8.5 and 13.5. Good. 8.5 and 13.5. So the way we're going to do that is look at which bars refer to that and which parts of which bars. So 8.5 up to 13.5 is going to be this one. And we're going to think, how do I get the area of that? What is the area of that? And you could use your table from the previous part of the question. And it's also going to be that. And annoyingly, because you might notice that this is bang in the middle of 10 and 15, that would be 12.5. So it's also one little skinny bit of this bar. And we're going to think, oh, how do I do that then? So the way we do this one, feel free to share if you think you've got an answer. So you can use the graph, you can use your previous answer, or you can use a combination of both. So yeah, good point. And if you've got the slides in front of you, then you could go, okay, let me just go back. Let's look at the table, see what I've got, and then add fractions of like the next bit. So what we've got here is we've got this first bit, 8.5, has got an area of 21. Then the next bit, lovely, and then we're going to add them together. Then the next bit would be 45. And then this little kind of skinny little strip that we're taking is going to be equaling to the 3 that we want. So it's got a height of 1 and a width. So that would, yes, that would be equal to 3. Add them all up and you do in fact get 69 motorists between that value and that value. So very well done. Some people got that already, so that's great. Hopefully that's clear, but we'll keep going because that's quite reassuring that we're working through that so well. And just bear in mind, like the question could even ask you, why is this an estimate? So just have in your head that if ever you're splitting a bar up from a histogram, exactly the same as linear interpolation, in that you're assuming just a nice normal spread of values between that one and that one. No, so this is the thing. It's a really good question. Generally not. I think if it's a really difficult scale to read, and you're kind of really struggling to see it, they generally give a tolerance of 1 or 2 either side. For something like this, no, because they've said estimate, it doesn't mean that there'll be an interval that they let you. You're supposed to know it's an estimate because you're splitting a bar up and you don't know how it's spread within that. So that's a really great point to pick up on there. So you would need that value bang on for this, really. But there's some questions, you know, where it's more about you're interpreting a graph, sometimes in the linear modeling in pure even, where it's to do with logarithms and stuff. It's very hard to read and, you know, raise to a power of 10 and so on. So there will be tolerance for that. But what I'm really stressing with the word estimate is that doesn't suggest a tolerance or that you can get away with doing it roughly or rounded or anything. This actually means that you're going by the knowledge that you don't know the raw values. So you're making an assumption that they're evenly spread in that group. Does that make sense? A bit like linear interpolation. So if you're going through and you're thinking, because they could ask that, they could ask, why is this an estimate? And you don't know the raw data. So it could all be grouped towards the 15 end of that box when you listed it out as a list of numbers. So that's the point. But yeah, really good question there. Right, this one. So again, I'll give you a chance to have a little think about this. We've got calculate the number of cars that were exceeding the speed limit. That's part A. So let's look at the question. So just in terms of the previous question, I've just seen the question in the chat there. we had to just find those areas. So 2 of them were from the table, and then the rest you had to work out the width and height, times it together and add it up. Right, good suggestions coming in. So we might want to go, okay, what area have I got there? Because overall, this represents 450 cars. Oh, sorry, my camera's blocking the question on this one. I keep forgetting that. So this is the information we need to start with. And the question actually states, calculate the number of cars that are exceeding the speed limit by at least exceeding, yeah, I can see that's really blocking the key point here. Exceeding the speed limit. Can you guys see what I'm writing here? Okay, yeah. Speed limit by at least. By at least 5 miles per hour. Okay, so that's what the question says. Sorry that my face is a bit blocking that one. So first of all, we're going to approach it in the same way as before. So we're looking at how many cars are exceeding the speed limit by at least 5 miles per hour. Okay, so we've got to think, well, how many cars are there in total? And what area have I got? And where can I go with that? So has anyone calculated the area here? And don't, I mean, it's annoying, you don't want to sit and count all those tiny little squares. But remember, we've got 5 by 5, and there's quite a few of them we can work out. Right, what are those areas are all 25. So let's work out the total area we've got. Has anyone managed to come up with that? And hopefully, by the sounds of how we're approaching this, we're aware that that might be the first thing we want to do, because we're dealing with splitting up areas in a proportional sort of fashion in order to work out separate parts. So if you've got an area in total, let's check. Now, I think that first bit is 37.5 as an area, if we're counting the little squares. And then this, I think, is 300, yeah. And then what else we got? 112.5 and 0.5. And here another 37.5. And then here, last one, what have we got as an area? 75. Add it all up. And hopefully we agree that the total area we've got is equal to 562.5. And now, can anyone suggest what we do with that? So I've worked all my area out. It's a little bit annoying for A-level maths that we're sitting there doing little squares and counting the areas and stuff. Right, well, this is a really good point, because this actually brings it all together. In a way, the scale on the y-axis doesn't really matter anymore, because at GCSE, of course it did. We had to make the area equal the frequency. But now what we're saying is at A-level, it needs to be proportional. So we can just deal with the area and see what the scale factor is, and then deal with the kind of frequency density there. So I'm kind of going by boxes. Absolutely. Let's just have a little think. So almost, we're going to actually do it the other way around. The way I would do this is say, well, 450 cars is represented by this area. So if we do 450 divided by, and there's other ways you could approach this. So if you have done it the other way around, that's fine. You might be able to work it from that way. What this will tell me, if I do that division, is that basically every one little box equals 0.8. That tidies up to 0.8 of a car, which sounds a bit weird, but every one of those little squares is 0.8 cars. Okay, so then to answer the next question, I know that that's what I'm using to scale my area by to give the number of cars. Okay, because what's a little bit weird about this one, yeah, so this is really stressing a key point here. We don't have a frequency density scale, but it's actually the whole process of this is showing us that the frequency density doesn't so much matter anymore if we can equate an area to a value. So we're kind of ignoring the fact they haven't put numbers on it yet, because we're sort of determining the scale. We're kind of going, well, I can see that I've got boxes, and there's like 5 by 5. There's 25 of these little boxes. So there's 37.5. So I do know that that's 5. and I know how many I'm timesing it by on a generic scale. So I can just equate the whole area I have as an area to the number and see what the kind of constant of proportionality is. So hopefully that's okay and that's clear what I've said there, because what's weird about this question is that this area is more than the actual frequency. So one little box is actually less than a car worth, which is a bit weird. So we've got some answers coming in. So that just means that no one was kind of doing that speed. So you don't need to count that bit. So good. So good questions, good points. And I think that sounds good. So for this one, for the amount of people that are exceeding the speed limit by at least 5 miles per hour, that means all the people that are doing more than 35 miles per hour, because the speed limit on this road was 30 miles per hour. So that total area is 112.5. And we know we have to times that by 0.8. So 112.5 little boxes, where each little box is 0.8 of a car, that will come out as a total of 90 cars. Okay, so very well done if you got that. And hopefully that makes sense. So this is a bit weird because we're kind of scaling it down to make it in line with 450 different cars, because the area was more than 450. And hopefully we can see then as well why the frequency density scale doesn't really matter if we're directly equating an area. So good. So we're almost there. We're doing really well with this. Next one, we'll just have a little look at. It's the same scenario, but this one says estimate the value of the mean speed of the cars in this sample. So we want the mean speed of the cars in this sample. Yes, I did. Yeah, I used the little boxes, which, as I said, it feels a little bit babyish in the way we're doing it, like counting little squares. We're not. I mean, we can speed it up. We can multiply a 5 by 5, so every big chunk is 25 and so on. But yeah, basically, we're just counting an area and equating it. Now, estimate the value of the mean speed. So here, again, we're assuming it's all uniformly sort of spread out within each interval, within each box. So what we're going to do here is think about, okay, this area, which is 0.8 times 37.5. So it's 37.5 is the area of this bit, but I know that that is times by 0.8 to actually give me the number. So if I do 0.8 times 37.5, I can go on and do that for everything now to find the actual amounts for each of these bars. And that would be 30 cars that's dealing with. And then I times that by their average. So the average speed of this is actually 12.5. So you use the midpoint of that interval to represent what their mean sort of speed is. So we're going to do 30 times 12.5. Is it clear where I've got the 12.5 from? Does that sort of make sense? Because again, it's an estimation. I'm assuming that on average, everyone in that bar does about 12.5. Bit like at GCSE, when you do estimate the mean from a table of group frequency, you assume the midpoint. That's basically what we're doing here. So good. So this next one, you're going to use 25. So you're going to firstly work out what this represents. And you're going to go, okay, well, I've got an area of whatever it is, 300. I'm going to times that by 0.8. So this is 240 cars doing an average speed of 25. Okay, and you're going to do that calculation for all the different intervals using the middle value as their average speed, and then work out that many cars times that speed. And then what do we have to do at the end when we've worked out all of these things added up? Yeah, super. Yeah, it's basically what you've done at GCSE, but instead of being presented to you in a table, it's presented in a histogram. So it's frequency times midpoint, and then you add them all up and divide them by the total frequency, which we know is 450. Spot on. So that was really good. And if anyone's got an answer, please feel free to submit that now. That'd be brilliant. And we'll see how we go. So we're going to do like 30 times 12.5, 240 times 25, 90 times 32.5, and so on. Yeah, good. Sorry, yeah, the only bit that's missing just says cars in the sample, yeah. So estimate the mean speed of the cars in the sample. So this is the kind of the main point of the question. So estimate the value of the mean speed of the cars in this sample. So it's talking about all of them. So there we go. So that's the key point there. Okay, anyone got a value? Anyone done it? I know some of you have flown ahead throughout this, which is brilliant. And it's also, we've all had a chance to kind of go through and work it out. Lovely. Right, so absolutely, you're going to add it all up, divide it by 450. So we do 30 times 12.5 plus, and we've got 240 times 25 plus all of these values. What was the next one? 90 times 32.5 plus I think this is the last one, 60 times 42.5. Yeah, that was the last value. All divided by 450. And I think I agree, 28.83. And remember your units as well, is it miles per hour? Spot on, good. So very well done there. It was a good topic to really sort of tease out misconceptions, the wording of the questions as well. And that was great. And it was great to see so many of you working through that, and hopefully having that link to the questions was useful. Very well done. So we've got the same answer there. So really well done with those questions today. It's a topic that's a really sort of small part of the overall course, but useful to go through because we know how important that can be. Thanks to you guys for all kind of taking part with that as well. And as usual, can I just check you can still see that bit of my screen now? Hopefully that's just changed. So we've gone from the PowerPoint. So as I've said before, we've got web classes on Snap Revise. I've got another one today coming up soon for year 12 and 13 and drop-ins. And these sessions get recorded and uploaded on the site, and they happen quite regularly. And I know some people who have joined along here today are some Snap Revise regulars. They take part in those sessions, and hopefully that's been really useful for you. I'm just trying to still see our chat as well, because I think my screen is a little bit small. Right, so the live maths ones, can you all still see that screen? Yeah, the live maths ones on YouTube will be on Mondays and Wednesdays at this time, so sort of 2 till 3. But there's loads happening every day on Snap Revise's platform. So please do, you know, if you've enjoyed this and you think it's useful, there's so much more on there. We have kind of all the content on the site, if you've been on the site before, is geared up for the new A-level. So in terms of, you know, being really focused for the different boards, the changes to the A-level, this stuff is bang up to date. And we kind of do diagnostic quizzes and loads of really easy, bite-sized, manageable stuff on there, and really clear, beautiful kind of notes that will help you get to grips with any topics you want to target your revision at. And I think particularly now where, you know, you're not at school and this is all down to you, you're kind of having to take ownership of your understanding and what you know. It can be really difficult sometimes, and it can feel like a really mammoth task of I've got to deal with a whole course, and you can break this down yourself. So hopefully, you know, that would be a really good thing to kind of invest in if you're finding this useful. What I'll do, if I just go back to my PowerPoint, I have got a discount code for those that have enjoyed this and I may be thinking about signing up there. So let me just check as well. Can you guys all see that again? Can you see my PowerPoint there? Yeah, excellent. Cool. I can just see your questions now. Sorry, I think it does. Yeah, that sounds right. And as I can see in the chat, and some people have commented about how it kind of works. Yeah, there is a lot of sessions that are just available for you to join and take part in. So, for example, you know, every day there's loads going on. There's drop-ins and web classes. And if you've got your own homework or your own question you want to bring, you can kind of email in or turn up and just ask it live in a session and we'll run through it. And hopefully that this was useful. It's great to hear. Thanks for that. It's really positive feedback there. And as I said, there'll be more on Mondays and Wednesdays, and we'll try and attack some of the big topics of the A-level course, but obviously we try and do it very extensively on the Snap Revise site and platform. So if you've enjoyed that, certainly something to think about. Cool. So, and yeah, and obviously, I mean, that's something you can cancel as and when, you know, if you've you finished your A-level, obviously, then you would cancel. But it's a platform that's available there for the whole year 12 and 13 course. So you can backdate, you can go and look at previous sessions as well. So feel free to kind of follow that up if you have found it useful and give it a try. But as I was saying, actually, this is an important point, because if you are interested, there's a discount code if you would like to try sign up, and that gives you a discount off your first month. So obviously very apt related to what we're doing today. So you can use that for if you're looking to join Snap Revise. But thanks very much again to all of you who've taken part in that. It's really helped. The engagement was superb and just really allowed us to get through that in a nice kind of efficient way. So really well done. Keep well, keep safe, and obviously, as I said, hopefully see you online on one of these sessions again. Very well done. I think that brings me to the end, so I'm going to stop sharing that there. Thanks, guys. Enjoy the rest of your week, and hopefully see you at one of these sessions again soon. Cool. And I'm going to stop that there.